Lesson, we have been working with radicals, so we are going to call this Simplifying Radicals Day 3. And today's going to kind of be a practice day, but also teaching something new, a new skill, but really just kind of adding on and building on to what we've already learned. So the first thing I have as a warm-up for you in today's Delta Math assignment is for you to do a multiplication table drill as a warm-up. So you're going to click on here, and your job is to get 25 questions right. I did turn the timer off. I know some of you don't like that timer. It kind of stresses you out, so I turned that off. And then you are going to go in here and do square roots with x, but everybody's going to get a different problem. So this is where we're going to pick up today, and I am going to, don't worry about the timer, we are going to work through a couple of these with, but put them in your notes when we get to the ones that have something on the outside already. So we should recognize that we have the square root of 9x squared, that the square root of 9, that is a perfect square, so the square root of 9 is 3. And also that we have an even exponent, so we just have to cut our exponent in half. So the square root of x squared is just x. So that would be 3x. So again, square root of 9 is 3. Cut this 2 in half, and that means we form one pair of x's. So if we take a look at this one, similarly, the square root of 4 is 2. Cut our exponent in half, and that gives us x cubed to form 3 pairs. So remember, if our exponent is even, we will not have a radical left in our answer. Here, I can't take the square root of 3, and if I expand out 3 x's, I'm going to have one pair. So 1x will come outside, leaving 1 on the inside, and that would be this one here. The square root of 16 is 4, so that comes outside, so it's one of these two. And if it's odd, and we divide by 2, we're going to end up forming 4 pair with 1 left inside. So one of the things we should note too is if we ever have a variable term, see how this has x to the 9th in the inside, and that has x to the first, and x to the 9th, it should never be more than 1x, as in x to the first. So this one makes sense, whereas this one, that's too big. We can't have 9x's because we would form pairs. So let's take a look at this one. And I'm going to start with adding this into our notebooks. And I'm going to call this number 4. You're going to add this into your notebooks. We'll just call it example 1, actually. So x to the 4th times x cubed. And I said that wrong. It's the square root of x cubed. So flipping back over here, I have x to the 4th times the square root of x cubed. So we talked about one similar to this yesterday, number 6 from yesterday's assignment, but these two things are separate, okay? So x to the 4th is its own thing, and the square root of x cubed means we are looking for pairs of factors of x when we have 3 x's being multiplied. If I have one pair, remember for every pair, 1 comes out, and that would leave me with x square root of x. But remember, we also have this x to the 4th. So when I'm multiplying this here, I have x to the 4th and also x to the 1st, which gives me x to the 5th. So if you can expand that out and count them if you want, or just recognize that when you multiply like bases, you add their exponents. So we would add 4 and 1 to get 5. Okay? Just because I think some of you like the expansion, and I think it'll be beneficial at least for this first one, this means we have 4 x's on the outside already and the square root of 3 x's. If we have a pair, 1 comes out, and that means we have 5 outside and 1 left on the inside. So whichever way works for you, but make sure that what you bring out, it gets combined with what is already here. So that's going to be x to the 5th times the square root of x. And that would be, for me, the second one. So now let's try this one. X squared times x squared times the square root of x squared. X squared times the square root of x squared. Now these should be at the top of your notes from yesterday. So this we keep. And the square root of x squared means how many pair do we form? 1. So if we multiply this x squared by this x, that gives us x to the 3rd power. And that's our final answer. But if you liked it better this way, there were 2 x's times the square root of 2 x's, where when we formed one pair, 1 came out. And that leaves us with x cubed. So decide which method you like. So on this one here, I cannot take the square root of 11, and I only have one x, so it does not pair up. So actually, nothing comes out. Here, 5 is a prime number. I don't have any pairs of factors. It's going to stay in. But if I have 4 x's and we split them into pairs, it's going to form how many pairs? 2 pair. So that's going to be this one. All right, and I'm going to stop and just we can add in a third example when it has multiple variables. So x to the 4th times x to the 7th. All right. So x to the 4th stays, and I just want to take this and simplify it. If I divide by my index of 2, how many pair am I going to form? I'm going to form 3 pair with 1 left over. So x times x, I add exponents. So that's going to give me x to the 7th times the square root of x. Again, if you prefer looking at it in expanded form, 1, 2, 3, 4, 5, 6, 7. Let's switch colors. So if I have a pair, if I pair it up, 1 comes out. For every pair, 1 comes out. For every pair, 1 comes out. So how many x's is this total? 1, 2, 3, 4, 5, 6, 7. And how many remain? 1. So that's going to take care of it. I'm going to then ask you to do a few of these as well for practice. So this is for notes, and then so what you're going to do is you're going to click on here, and you have 5 of these to complete. Okay, so make sure that each of those 5 that you do are in your notebook. Then you're going to come down here, and I'm just going to review with you really quickly how we find the square root of non-perfect squares. I have to refresh because it wants to be stuck. So for problem 4 here, we have the square root of 80. So remember, if I'm doing actual Delta Math problems, make sure you're putting them in your notebook because you will need to enter them in yourself into Delta Math. So the square root of 80, is it a perfect square? So if I use my calculator, and I'm going to model as if you were doing this at home with your Calculate 84 app. If I take the square root of 80, I get a non-terminating, non-repeating decimal. So that tells us it's a non-perfect square. So that's when I go to y equals and I type in 80 divided by, try to make this a little better, 80 divided by x squared. Then I hit second graph, start here at 0, and then I look for the last integer, or in other words, whole number in this case, ordered pair. Once I get to 0 point something, I've gone too far, so my last whole number order pair is 4 and 5. So again, write this down. I'm going to y equals. I am typing in my radicand 80 divided by x squared. I am looking on my table for the last integer ordered pair, which is 4, 5. And then I'm using that to write my answer. So remember, it would always be x root y, or in other words, 4 square roots of 5. So the first number comes down, the second number goes inside the radical. So that's just a quick review of a problem where we have the square root of a non-perfect square. So numbers 5 and 6 are for you to do. If you want to pause the video now and do 5 and 6 the same exact way I just did 4, you're welcome to do that and then resume the video. For number 7, I'm going to do a couple of these with you. These are simplifying radicals when you have something out front. So it's just adding on a little bit to what we did in the prior lesson. So this is number 7, which is 7 square roots of 12, x to the 6th, y to the 4th. So in my notebook, because everything should always be done in our notebooks, I am going to recognize that this 7, I'm just going to come down here, and this square root are two separate things being multiplied, okay? So I'm going to bring this 7 down here and multiply it by whatever I get when I simplify this. So if the 7 weren't there, how would we simplify this? This is just like yesterday's lesson. So for 12, 12 is not a perfect square. So if I type in 12 divided by x squared, then look at my table. My last integer ordered pair is 2 and 3. Okay, 2 and 3. So that tells me I have 2 square root 3. But notice how I'm leaving space so I can write in my variable terms. Remembering that for x to the 6th, y to the 4th, if it's even, all I have to do is divide by the index. So that would give me x cubed and y squared. Now remember, if you're the type of person that prefers expanding it out, then you are welcome to do so. That's going to form 3 pair of x's and 2 pair of y's. Now, why is this different from yesterday? Because if we have a 7, then I need to multiply whatever's on the outside by my answer. So 7 times 2 would be 14, then my variables, then the square root of whatever is left under the radical. And this is my answer. And that's how you would type it in. So if I go to Delta Math and I have to type it in, it's going to be 14x shift 6 to get the exponent of 3, hit the down arrow, then y shift 6 to type in squared, come back down. Then you've got a couple options. You have a square root, a cube root, and an nth root. We only need the nth root if we're finding something like the 4th root or cube root or 4th root or 5th root or higher. So just keep using the square root for all of these answers. And the only thing left is a 3. Okay? Then it basically explains what we just did there, maybe in a more complicated way. So let's try again number 8, where on number 8 we have, this one's different in that it has an odd exponent. So I want to do this one. So I'm going to write this down first. Oops. So this is number 8. I'm writing it down in my notebook. And we're going to do the same thing we did on the last problem. So I'm going to first recognize that I'm multiplying two different things. So I'm going to have this 7 down here times what I get when I simplify all of this. Well, what do you know about the square root of 25? The square root of 25 is 5. If I have 7 x's and I divide that 7 by my index of 2, like we did before, then I'm going to form how many pair? So for those of you that need this, 1, 2, 3, 4, 5, 6, 7, and then 6 y's. I tend to write them under each other, like one variable and then another variable, rather than write them out all to the side, but you can do it to the side if you like. So how many pair of x's am I going to form? 3. But I have one x left over. And then I have how many pair of y's? 3 pair. So I'm not quite done, because whatever I had originally, I need to multiply by this answer. But the only thing I can do is multiply 7 times 5, which is 35. And that's all I have. So I'm going to do, let's see, one more, and then you'll have 4 of these to try on your own. I believe number 9, I have one with a variable out front. Yes, I do. Okay? All right, so for number 9, I've got 5y times the square root of 4, x to the 4th, y to the 6th. So I've written my problem out. Again, I need to look at the part out here separate, so that's 5y times this part here. So I'm putting blanks so I don't forget the 5y, and then I have to multiply. If I simplify this, the square root of 4 is 2. Remember, with even exponents, those are the easiest, because all you do is divide by that index. So that means I would form 2 pair of x's and 3 pair of y's. Again, 1, 2, 3, 4 x's, 6 y's. So this is where I get x squared, 3 pair of y's, and that's where I get y cubed. Now keep in mind that when we multiply what we already had times our new simplified version of the right side, 5 times 2 will give us 10. In alphabetical order, I'm next going to put x's. And now I have 1y being multiplied by 3 y's. So remember, when I multiply like basis, I add the exponents, which gives me y to the 4th. Or keep in mind that this is 1y times 3 y's, and together that makes 4. And that's what you would type in. All right? So that concludes the video. Just please go back and finish all other Delta Math problems. Complete this and take pictures of all your work. Your work means write the problems down, the work down, and the answers down, and take pictures of those and submit them into Canvas. Let us know what you need help with.